All right, today, guys, we are looking at lesson 43. And lesson 43 deals with simplifying rational expressions. We're going to be doing problems like number 4 in the Bell work, I believe it was, the one that simplified to 1 minus 7x, the one that Sean bailed us out on over here. And we're going to add the wrinkle to it. We're going to find undefined or excluded values for rational expressions. We've mentioned this before. And we've had this conversation in a couple of classes prior to this. What makes an expression undefined? Division by 0. So the denominator of a fraction cannot be equal to 0. If the denominator of a fraction is equal to 0, then we have an expression that is undefined. So if we have a variable expression like 6 or 2 minus x, that's a pitiful 2. 6 over 2 minus x, what can x not be equal to?
2.
X cannot be equal to 2. Because if x is equal to 2, then our denominator has a value of 0, and division by 0 is undefined. So the excluded value for this expression, when we talk about excluded values, we're talking about what x cannot equal. X cannot equal 2 in this expression. All right, so that's called an excluded value for an expression because it would make the expression undefined. These are excluded values. Very, very, very important concept in Algebra 2 and college algebra. Okay, graphing rational functions this comes into play. All right, so rational expressions are fractions with a variable in the denominator. We already know that. And we just discussed that since division by 0 in mathematics is undefined, the denominator of a rational expression must not equal 0. It cannot equal 0. So we will have to exclude any values that make a denominator equal to 0. Okay? All right. So here's example number 1. Let's put these things into play. Determine a value or values for which the rational expression is undefined. Determine the values of what? Of the variable, right? If we're determining values, we certainly can't change the value of 8. We can't change the value of 4. We can't change the value of any of our constant expressions in this rational expression. The only values that we have any control over are the values of x. So in this particular expression, what can x not be equal to? X cannot equal 0 because if x is equal to 0, then our denominator is equal to 0 and our expression is undefined. This is a simple skill, right? Determine the values for which this rational expression is undefined. X equals 4 would make it undefined, so how are we going to express that answer? X cannot equal to 4. Now, if you're going to say x equals 4, we need to say what x equals 4 is. You'd have to say x equals 4 is excluded. Now, you determine which one you want to use.
It's not.
Okay, it's really it's a no-brainer, right? We want to say x cannot equal 4 just because it's easier to write it that way. Okay, all right, what about this one?
X cannot equal 7.
X equals...
X cannot equal negative 7.
X cannot equal
Negative
7, right? Because, and if you needed to come off to the side, you could do that. 3x plus 21 cannot equal 0. So that would solve for the excluded value. Your denominator cannot have a value of 0. Subtract 21 from both sides. 3x cannot equal negative 21. We solve an inequality the same way we solve an equality. Divide both sides by 3. X cannot be equal to negative 7 is our excluded value for that rational expression. Okay, what about this one?
X cannot equal negative 1/5.
Negative 1/5 is correct, right? Because, again, if we show the process, 5x plus 1 cannot equal 0. Subtract 1, divide by 5. X cannot equal negative 1/5. All right? Good? All right, so those are excluded values. Now, where you're going with this is going to be different. Now, have we were kind of chugging along here. Have we followed the directions of this assignment? What did the directions say here? Simplify the rational expression, then determine the excluded values of the variable. Did we simplify it?
No.
I don't know. Is it simplifiable? How do you simplify fractions? By canceling common factors, and we can't find common factors without factoring, right? So I need to factor this expression. The excluded value is -1/5, and you really can do that at the beginning. You should do that at the beginning. All right, can we factor the numerator?
Yes.
What can factor out of the numerator?
9.
So this expression is equal to 9 times 6x plus 1 over 5x plus 1. Can it be simplified? Do we have any common factors? No, 1's not a factor. I mean, 1's a factor of anything. It's hanging out here 1 times all this stuff. But yeah, 1 is not a common factor. Are y'all talking about this one right here and this one right there? Come on now.
Talking about that one.
Yeah. No, this isn't a factor. This isn't a factor, and neither is this. These aren't factors. Those are terms of a factor. And you cannot cancel factors or parts of factors.
No.
Terms, excuse me, you can't cancel terms or parts of terms. You can certainly cancel factors. So, what are the factors of this expression? This is a factor. This is a factor. This is a factor. Are any of those factors the same?
There's 6x plus 1. 5x plus 1.
No, there's no factors that are the same, so this expression is already simplified. Okay, and the excluded value is x cannot equal -1/5. What could we change it to make it a simplifiable expression?
What do you mean by changing?
What if this were 45x plus 9 over 5x plus 1? Would that be simplifiable? Pay attention. Everybody pay attention.
Yes,
What could we factor out of this?
9.
9 times
5.
5x plus 1 over
5x plus
5x plus 1. Now I have two common factors that can cancel, right? The 5x plus 1s can cancel. And this is equal to 9, as long as x is not equal to -1/5. And this is why the excluded value is important. If you don't pay attention here carefully and closely, you're not going to catch this. The excluded value qualifies the equal sign. If I put -1/5 into this expression right here, it's what?
Undefined.
It's undefined. Is something that is undefined equal to 9?
No.
No. So this expression is only equal to 9 as long as x is not equal to -1/5. So the excluded value is extremely important to qualify the equal sign in this expression. These two expressions are not equal if x is -1/5. If x is anything else, then they are equal. Okay? If x is 0, what do we have here if x is 0?
1 over
9 over 1, which is 9. If x is 1, we have 54 over 6, which is equal to 9. It's always going to be equal to 9. But if x is -1/5, it's not equal to 9. So knowing the excluded value is going to help us out there. Hadley.
Do you always have to put like the excluded values down?
Yeah, I'm going to remind you of this moving through. This is one of those skills that some people are going to really understand and others are not. By the time you get to Algebra 2 and you've seen this again, and you get to college algebra and you've seen it for the third time, then it really starts to sink in. Pre-calculus, you'll do this kind of skills. So you guys are on the pre-cal track. So you'll see this several times in mathematics. The excluded values, simplifying rational expressions is a big deal for calculating limits in calculus to a lot of other things. All right, everybody try this one on your own. Simplify the rational expression and determine any excluded values of the variable. You're going to have to pick up a writing utensil to do this.
That's not nice.
It's not my job to be nice. It's my job to teach. Sometimes teaching requires a little meanness.
A lot of meanness for some people.
Jay. All right, 2x squared minus 10x over 4x squared plus 6x. Simplify and determine the excluded values of the variable. Simplifying fractions involves canceling common factors. And to find the factors, we have to factor the expression. So the first step is going to be to factor the numerator and denominator using a GCF. All right, so if we factor the numerator and denominator, what can we factor out of the numerator? 2x times x minus 5. What can we take out of the bottom? We can take out a 2x, and then we're left with
2x plus 3.
2x plus 3. Okay, now the 2x's on the outside of the parentheses can cancel each other, and we're left with x minus 5 over 2x plus 3. Right? Now here's the tricky part of this one. Excluded values. What can x not equal? Negative 1/2.
I got 3 over 2.
Negative 3 over 2.
I got right positive 3 over 2.
That would work too.
Dakota Avenue.
It's going to have to be negative 3 over 2.
3 over 2, which is 1 over 2.
And what else, Sean? 0. All right. Now this kind of really is a little bit advanced. It's a little past what we've learned at this point. We've not found a quadratic, but let's kind of go back up to the original problem. Are y'all listening to me? If we go back to the original problem, we are dealing with 4x squared plus 6x. Just wait just a second. Put your hand down and watch this. 4x squared plus 6x equals 0. How many solutions is that supposed to have? 2. Why does it have 2 solutions? Because it's squared. And we said at the outset of the class that a second degree polynomial expression has 2 solutions. So we need to be mindful that there's 2 values that are going to make that denominator 0, or there could be 2 values that make it 0. Those 2 values come from these factors, right? If either one of these things, if this thing is 0, pay attention. If this thing is 0 or this thing is 0,
Then that means there's 0.
then 0 times anything else is going to be 0. So when is 2x equal to 0? When x equals 0. When is 2x plus 3 equal to 0? When x equals negative 3/2. So once you get your denominator factored, you would set each factor not equal to 0. 2x cannot be 0, which means x cannot be 0. 2x plus 3 cannot be 0, which means x cannot be negative 3/2. So our solution is x minus 5 over 2x plus 3 as long as x is not equal to negative 3/2 or 0. Now, listen, this is tricky, but you guys are honor students, so I expect some of you to be able to catch this. In my college algebra classes, and if I teach algebra 2, I do the same thing. I do not exclude negative 3/2 in this situation. Why might I not exclude negative 3/2? Think it through. In other words, you can, it's okay to do it, but you do not have to include that excluded value. Karis.
Like in the original expression, if you like put negative 3/2
It's
in for x,
It's still undefined. That's right. It's still broken, right? Negative 3/2 breaks everything. 0 breaks this. 0 breaks this. 0 does not break this. Okay, that's why it's important that the 0 be excluded. Negative 3/2 doesn't have to be excluded to qualify the equal sign. Okay, but we're going to leave it in there. I don't want you guys to think so much about that. It doesn't have to be excluded, so but we can exclude. You can always exclude a value that makes the denominator 0, but you don't have to exclude it because negative 3/2 breaks everything. This is undefined at negative 3/2. That's undefined at negative 3/2. That's undefined at negative 3/2. So they're equally awful at negative 3/2. But they're not equally awful at 0. 0 works perfect in this last expression. 0 doesn't work in any of the other expressions. And I got like scribbles everywhere. Okay? Any questions there? You make a lot of sense out of that as it develops. All right?
Well,
One more.
that was pleasant.
Simplify the rational expression and determine the excluded values of the variables. Okay, is everybody about done? Griffin, walk me through it.
Okay, so you factor out
Factor in the numerator. What do we factor out of the numerator?
2x
2x times
x minus
x minus 7. Okay.
and factor out the denominator, and you get
4 times
4x minus 7.
x minus 7 is correct. Right? And then what can cancel? Watching this. The x minus 7s can cancel. What else can cancel? 2 over 4 simplifies to be 1/2. So my final answer here is x over 2 as long as x is not equal to, not negative 7, 7. Why can't it be 7?
Because then it's 28 minus 28.
Right. So, and also, if I put 7 in here at the end, 7 over 2 is
3.5.
3.5, right? But if I put 7 in up here, I get 0 over 0, which is undefined. Is something that is undefined equal to 7 over 2? No. So this expression has to have that 7 excluded in order to qualify the equal sign. What's your question, Abby?
I don't really know what my question is. I don't know.
She's so confused she doesn't know what she doesn't know.
I understand how you get both values, but I don't understand how when you plug it in, it doesn't work in both situations.
All right, so that's the part of it that at this point I'm not necessarily concerned that you don't understand. It's safe to always exclude values that make the denominator 0. Okay, if we were dealing with a function here, we have to exclude every value that makes it. But the values that make a denominator 0 that go away when you get to rational functions, they're different kind of bad spots. Okay, I know it's difficult, right? But if we, gosh, yeah, let me show you this. I want to show you. All right, let's just suppose we started out with. I'm going to give you a rational expression that's all factored out for you. Let's suppose we started out with y equals, and this is a function, now throwing y in the mix, y equals x plus 3 times 2x minus 1 over 2x minus 1 times x plus 5. Okay? What's that equal to?
3x.
That's equal to x plus 3 over x plus 5, because you can cancel those two common factors. This is equal to that as long as negative 1/2. Not negative 1/2. Positive 1/2. Right? Because 2x minus 1 cannot equal 0 means x cannot equal positive 1/2. Right? So what I'm saying is here is that this expression that we started with, this whole expression here, is equal to this expression, but only if x is not 1/2. Okay, this is a great question. Okay, can x equal negative 5 in this expression?
Yes, because you'd still multiply times 0.
All right, so what she's saying is that if x equals negative 5 up here,
It's also equal to.
or if x equals negative 5 down here, they're equally awful. They're both undefined. So that they're still equal to each other in a very, very bad way. Okay, so we don't have to exclude it. Now, to answer your question, x also cannot equal negative 5, right, in this expression. Graphically, and you're not going to understand what I'm about to tell you, graphically, this is called a hole in the function. This excluded value is called an asymptote. Okay? And we'll learn this expression actually next semester. We'll learn what an asymptote is and how to graph it. All right? So, two different kinds of discontinuities. Discontinuities, something that breaks the function. Something that breaks the expression. Okay?
If we were given this problem, would we have to write the 1/2 and the
Okay.
negative 5?
At this point, I don't care if you write them both, or if you understand this concept and you just want to write the one excluded value that has to be excluded, write that one. Because I want you to be able to tell the difference between the two. It's always safe, however, to exclude them both. Yeah, Griffin.
Which one has to be excluded?
The 1/2.
Because it's the whole.
Because 1/2 breaks this part, but it doesn't break this part. Negative 5 doesn't have to be excluded. It does graphically, but if we were just talking about an expression, it doesn't have to be excluded because negative 5 breaks everything. So they're equal. They're always equal at negative 5, but the two expressions are not equal at 1/2, so you have to exclude the 1/2. Yes.
So the only one you have to have, like in an expression, is the one,
One
that
that-
breaks the original.
The one that breaks the original but not the other one. It's the one that you
Yeah.
cancel. The one that you remove from the problem has to be excluded. Okay? And actually, when you get into Algebra 2 and pre-calculus, that little broken part, the 1/2 in this problem, is called a removable discontinuity. It's a bad spot in the function that we can remove. We can take it out. Okay? The x plus 5 that hanged around in that last problem, can I pull it back up? The x plus 5 that hanged around there that stuck with us through the problem is called an infinite discontinuity. We cannot fix the function at that point. It's infinitely broken. Okay? So that's some deep function analysis that I just gave you. But it's kind of an explanation of why I want you to be able to differentiate between those two types of bad spots. They're both bad spots, right? 1/2 is very bad because it gives you 0 in the denominator. Negative 5 is bad because it gives you 0 in the denominator. But they're different kinds of bad. Yes.
If like a problem tells us to simplify the expression and then find the excluded variable, would we exclude the variable for the one that we simplified?
I want you to exclude the values from your original problem for this point. Yes.
Okay, I don't understand how you got the 1/2.
Okay? All right? All right? Yeah, watch. No, it's okay. It's okay. We're going to run out of time if we have to have a conversation about her question. 2x minus 1, this thing right here, cannot equal 0. So if you add 1 to both sides and divide by 2, x cannot equal 1/2. That's where it comes from. Okay? So you have to exclude it. It cannot equal 0. We're not going to have time to do that last
So
example.
it's more important to find the one that you have to exclude with the two factors that you.
At this point, it's hard to say that one is more important than the other, but I want you to always be able to differentiate between those two. I always want that one. The one that cancels, that one that we have to exclude that one because it qualifies the equal sign. Okay?